Finding trends, patterns, and relationships within text corpora is challenging to address interesting questions such as, what are the hottest political topics last month? Are there any common viewpoints among different groups of people? And how does the wisdom of the crowd change over time? This video demonstrates DycomDetector, a novel approach for topic modeling using graph partitioning algorithm to extract clusters of important terms that form latent communities. We use data collected from different sources such as Huffington Post, Empty Wheel, and Esquire. The important terms are extracted, classified, and color-coded by category: blue for people, orange for location, and green for organization. At each timestamp, a network snapshot is constructed where links are computed based on term co-occurrences in the same articles. Users can redefine the networks based on different settings such as vertex degree, betweenness centrality, or collocation frequency. Communities become visible in the refined networks. A histogram below each network displays computed modularity on different filtering of collocation frequency. Below each histogram, DycomDetector displays the top 5 terms in the above network based on the selected feature. At the bottom, we show the evolution of terms over time in small multiples. Arc diagrams are overlaid on top to show term co-occurrences. Terms in the same month are ordered by community to reduce edge crossings. Here are some detected political events in this example. Box A contains the Sandy Hook Elementary School shooting occurred in December 2012 in Newtown, Connecticut. Box B referred to the Boston Marathon bombing in April 2013. We can see some arcs connect Boston Marathon and Sandy Hook since both of them involve human lives. The next event relates to Edward Snowden, a former CIA employee who leaked NSA classified information. As shown in Box C, this is still a hot topic in the next few months. Box D is the shooting of Trayvon Martin. The policeman Zimmerman was not found guilty of Martin's murder in Sanford, Florida. DycomDetector supports a range of interactions such as lensing or filtering. For example, users can refine the networks by the sudden increase in term frequency, vertex degree, betweenness centrality, or collocation frequency. Node sizes reflect the selected feature. Users can also use the search box to narrow down the topic of interest. For example, one can input NSA. Through the support of DycomDetector, we can visually detect term communities associated with interesting political events, such as the triple homicide that took place in Waltham, Massachusetts. Todd Sheff is the murderer and also a friend of Tsarnaev, the Boston Marathon bomber. The second cluster contains Undai-Bomb, Al-Qaeda organization, and people such as John Brennan, the CIA director, and Fahd al-Qawso, a terrorist. Topics in other months relate to Edward Snowden, who leaked NSA information, James Clapper, the former director of national intelligence, and the argument between John Kerry and Assad, the president of Syria. In the last case study, we demonstrate DycomDetector on the IEEE VIS publication dataset. The top left panel shows statistics of this data such as the number of papers in each visualization venue, orange for VEST, green for InfoVis, and red for SciVis. The top left thumbnail summarizes publications from 1990 to 2016 in these venues. Now, we focus on Edward Grallers, who published the most papers in VIS conferences. Grallers is in the center of each network snapshot, and the detected communities associate to Grallers publications. In the time series, we can easily spot researchers who have strong collaborations with Graller over years, such as Jürgen Wasser and Stefan Bruckner. The pop-up window displays researcher profile on mouse over. We can notice by the colors that he had papers accepted in all visualization venues. More case studies can be found in our paper and project website.